Okay, welcome back. It's section 7.2, division properties of exponents. So 7.1 is multiplication property. Now we're going to talk about using these to the different ones with the division properties. And then we're going to use these properties to simplify expressions, and we're even going to introduce to you zero and negative exponents. So quotient of powers, quotient of powers. So again, same thing we did last time. We're going to go through the example first and then show you what the shortcut is. But let's take a look at an example of, say, it was x to the 7th over x squared. So in this case, if we were to write it all out, we would have x times itself 7 times on the top, on the numerator, 6, 7. And then in the denominator, we'd have x times itself twice. Well, what would end up happening is that 2 of these would cancel each other out. This one would cancel with this one would cancel on this one. So what do we have left? On the bottom, we've got just a 1, right? Because there's nothing left. So it doesn't go to 0, it just cancels to 1. And then on the top, there's 5 x's left, so it'd be x to the 5th power, which we could easily just write x to the 5th. Well, the shortcut here says keep the base and subtract the exponents. So it's just the opposite of multiplying, where we added the exponents. In this case, we're going to subtract them. So you're going to keep the base number the same as x, so x stayed to x, and then you're going to take the 7 and subtract the 2. And just subtract the bigger number from the smaller, just in case we see a situation where the denominator's number is larger than the numerator, we can still subtract that as well. So x to the 5th power, power of a quotient. So in this case, we will look at the example. It says, let's look at x over 5. And we'll put that in parentheses, and then to the 3rd power. So if we were to write this one out again, we would go x times, we're looking at x over 5 times x over 5 times x over 5, which would actually, when we multiplied this out, we'd have 1, 2, 3 x's, so it'd be x cubed. And then 5 times 5 times 5 is 125. If we look at our shortcut here, our shortcut says distribute the exponent to the numerator and the denominator, just like we did with powers of powers with multiplication. So in this case, if we take a look at distributing that 3, the 3rd power to the x would be x to the 3rd power, basically this result right here. And then we could also do that 5 to the 3rd power, which is 125. So that would be our shortcut. Instead of having to write all this down here, you can just simply go x cubed over 5 cubed, or 125. All right, zero exponents. Zero exponents is my favorite because it's very, very simple. Anything to the 0 power equals 1. All right, anything to the 0 power equals 1. So if we look at the example, say we had x to the 15th power, y to the 24th power, and z to the 9th power. Okay? If all of that together was to the 0 power, what's that going to be equal to? 1. Just 1. Don't get confused with all that other stuff. Anything to the 0 power is 1. So all this stuff in parentheses here would be just equal to 1. Anything to the 0 power is 1. Okay, but you have to be careful a little bit on that one, because let's say it was not in parentheses. Let's say we had an example where it was x to the 15th power, y to the 0 power, and then z to the 9th power. Okay, well, in this case, there is no parentheses, so the only one that's 1 here would be this y to the 0 power. This would be the only one that would be 1. Okay, so your answer here would still be x to the 15th, z to the 9th, because you'd have that 1 in there. So just be careful with your parentheses. But other than that, 0 power is pretty easy. And then negative exponent. All right, negative exponent is what we're going to do here is, if you were to look at it, we're just going to give you the shortcut here. What we end up doing is we're going to use the reciprocal of the base and then make the exponent positive. Okay, so if we take a look at the example, we look at say the base. What's the base here? The base is 5. So what's the reciprocal of 5? The reciprocal of 5 is 1/5. So I would take 1/5 and I'm going to make the exponent positive. So it's going to be 1 over 5 squared. Okay, and the base, the exponent still stays with the base. So we make it a reciprocal, it makes it 1/5, but this 2 is going to stay with it. We're just going to make it positive. Just going to make it positive. Okay. The other things you hear people say is they might use the phrase. We'll just write that down here. Flip the base, because we're talking reciprocal. So flip the base. To the opposite side of the fraction. And make exponent positive. So that's another way to say it, and it kind of, we're out of T there. It's another way of saying it is flip the base to the other side of the fraction and make the exponent positive. So in this case, it was like a 5 over 1. So the base number would be the 5. So we flipped it to the other side of the fraction and made the exponent positive. So down here in the second example, 1 over m to the negative third power, we're going to flip the base to the other side of the fraction. So it would be m over 1, which we really don't even need that m over 1. So we just flip the base to the other side of the fraction and then make the exponent positive and just be m to the third power. Okay? So flip the base and then make the exponent positive. All right. Let's simplify some of these then. We look at number 1. All right. And the same thing I'm going to do as we did on the last assignment yesterday is I'm going to show you the shortcut first, and then we'll kind of write it out to make sure that we're getting it right. So the first thing we can do here is let's take a look. We would have the a's. We got a to the 5th. Remember, if there's nothing here, we can assume it's a 1. So a to the 5th over a to the 1. So we would subtract those exponents. We're going to keep the base, do one shortcut, and we're going to subtract the exponents. 5 minus 1 is 4. Same thing with the b's. Now remember, this is the example where the denominator actually has a larger number. So we could go 3 minus 2. Just make sure that we keep our b's down here then. 3 minus 2 is 1, which we really don't even need to write that 1 down. It would just be a to the 4th over b. Okay. Now let's write it out to make sure that that makes sense. So over here we would have a 5 times, and then times b 2 times, because b squared. And then the denominator would be a times b times b times b. And so this should kind of help you by canceling out, see how it makes sense. This a here is going to cancel with this a, and then these 2 b's will cancel out. So what are we left with? We've got 1, 2, 3, 4 a's. That gives us our a to the 4th here. And then we've got just 1 b at the bottom. So that gives us our a to the 4th over b. So you can write it out and it'll work. If you can use the shortcuts, that'll be great. With the shortcuts, just be careful that we have to, when we're talking about negatives, you have to ask yourself, is the negative on a number or an exponent? Because if it's just on a number, then we don't really have to do anything with it. Like this -2 and this -6. That doesn't mean we have to do any flipping. Because the -2 and the -6 are just numbers. If the negative is on an exponent, that's when we would have to do some flipping and making it positive. So in example number 2, we really don't have to do any of that. We can separate this fraction and make it -2 over -6. Okay, which we know is going to reduce to 1/3, but we'll get to that in a second. And so now it's basically k squared over k to the 6th. So if we just kind of separate them there, then we're in good shape. So now let's go ahead and use our shortcut, see if we can get the answer. -2 over -6. If I asked you to simplify that, just that part there, you would say, well, that's positive 1/3. Negative divided by negative makes it positive, and it reduces to 1/3. And then we've got k to the 6th and k squared over k to the 6th. So we can subtract those exponents, and since the denominator is larger, 6 minus 2 is 4. We're going to keep that k on the denominator then. So it'll be 1 over 3k to the 4th power. Okay, let's just write that out to make sure it looks the same. So if I went ahead and said, well, this would be k times k. On the bottom, we'd have k to the 6th power. So I'd write it 6 times. And so again, like I said, we're going to cancel. And so there's just 1 left on the top. And on the bottom, we've got 4 k's. And we've got this 1/3 there. So still, that's how we got our answer. Okay. Plenty more examples we can look at. And we'll do that throughout. Let's skip those and go right to this one here. This one's a pretty simple one because we've got a negative exponent reciprocal. So now in this case, the negative is with the exponent. So now we're going to have to do some flipping and get the reciprocal. Okay. So in this case, we're looking at it and saying, well, what's the reciprocal of 7? It's 1/7. And then we're going to make that exponent positive, make it 1 over 7 squared. Or flip the base to the other side of the fraction. Right now it would be like 7 over 1. So we're flipping it to the other side of the fraction, and we're making an exponent positive from a negative to a positive. And we could calculate this out. 7 squared is 49, so it would be 1 over 49. Let's look at number 8 over here. There's a lot of action going on this way. Okay, again, in this case, we're going to have to do some flipping. So 4 and the 5 are just going to kind of go away because, they're not part of this. It's 4 times c cubed and 5 times c. So the 4/5 is just going to eventually kind of be a 4 and a 5 here as well. So let's take a look at our c's and our d's. So one thing we can do is let's look at the c first. So I've got a -4. So one thing we want to do is we want to bring that to the other side. Okay, we're going to flip that c, bring it to the other side of the fraction, and then make that exponent positive. So I'm actually going to say, I'm going to make that up there and just write a c to the 4th up here. And then I can get rid of this down here. Get rid of it down there. Same thing with the d's. Same thing with the d's. So with the d, I have to take this d to the -2. And I've got to bring that to this side here. So I'm flipping the base to the other side of the fraction. And I'm going to make the exponent positive to make it a +2. And then I can kind of get rid of that d as well. So now I've already wrote the 4 down. Now I've got c to the 3rd times c to the 4th. Well, that's going to give us, in our shortcut, we just add the exponents now. So it's just 4c to the 7th. And now with our d's down at the bottom, we've already got the 5 written down. Now we've got d to the 7th and d squared. So our shortcut when we're multiplying exponents with the same base says add the exponents. So the d is going to stay the same, and then 7 plus 2 is 9. 4c to the 7th over 5d to the 9th power. Okay? If you were to actually write that down again, let's go ahead and do that. Let's just start with after we flipped it. So we'll just kind of look at it and say, once we had 4c cubed, and then c to the 4th after we flipped it and brought it to the front. And then down here we'd have 5d to the 7th d squared. Okay, so after we brought it and flipped it over to the top. So basically what we did was, again, here we have 3 c's, and then we have 4 more c's. Down here we'd have 2 d's, and we'd have our 7 d's. And we'd have these 2 more d's. So you can see where it would add up. Okay? All right. Let's skip those. Let's go to this one. We got an area problem here. Area of a rectangle is 32 x to the 4th, y to the 6th. So find the length of the rectangle. Okay? So if they want the length, we're going to say that this is, well, we know the area formula for a rectangle is length times width. Okay? So they want the length, so that's this missing piece. So we're going to assume that this is the width. Okay? So they want the length. So first thing we're going to do is just kind of rework this equation and say, well, how do we solve for the length? Because they gave us the area is that, and they gave us the width here. So how can we solve for L? So if we remember how to solve for variables, I'm just going to divide by the width. So these cancel out. So W basically equals, L basically equals A divided by W. Okay, so knowing that, now I can plug in those numbers. The area was given to us in the above example here, 32x to the 4th, y to the 6th. And then the width was given 8, x to the 3rd, y squared. Okay, so now we can work with this equation and find our length. So, using the shortcut, well, we know right away here, 32 divided by 8, that's going to be 4. And then I can go ahead and say, here I got x to the 4th divided by x to the 3rd. We subtract exponents. Remember, we subtract exponents. So x to the 4 minus 3, so it'd be x to the 1st power, because 4 minus 3 is 1. And then finally here, we've got y to the 6th over y squared. So I would subtract that, y, and then 6 minus 2 is 4. So 4xy to the 4th power. And you could write that all out again, and you'd get the same answer there. Okay, that takes us to the lesson summary here. I want to know the answer. What do you do when you have a negative exponent? And let's add to it, what about a 0 exponent? Just so we're answering those questions as well. And then finally, our practice problem is to simplify this. You've got x cubed times x to the 0 power times x to the negative 5th power. So it kind of gives you a little bit of everything there, too many x's. And if it helps, put it all over 1 because you're going to have to do some flipping with that negative exponent. Okay? Bring your questions, and we'll answer anything you have for us tomorrow. That's it for 7-2.